At the network layer, we identify nodes by an IP address. At the link layer, we identify nodes by a MAC address. MAC stands for Medium Access Control. An IP address is, of course, either 32 bits or 128 bits, depending on whether you're using IPv4 or v6. A MAC address in Ethernet is 48 bits, which we will normally write as 6 8-bit numbers, written in hexadecimal, separated by dashes, or sometimes you see them by colons. I'll use dashes just to distinguish them from IPv6 addresses. We know there's some structure to IP addresses. They're hierarchical and roughly by proximity, at least enough to be useful for routing. MAC addresses have a more limited structure, and they're hierarchical by manufacturer instead of location. So A4 at the beginning here might represent the manufacturer of an Ethernet card. And where an IP address needs to be configured by something like DHCP, a MAC address is in principle burned into the hardware. So when you get an Ethernet card, the Ethernet card knows its MAC address once and for all. That's why the addresses are organized by manufacturer. And 48 bits is enough for every Ethernet card to have its own unique identity. So anytime it participates in a network, it can be sure to have a different identity than all the others. I say identity here because a MAC address is more like an identity than an address, although it plays the role of an address as a MAC joins a network. It's also a little bit of a simplification to say that a device has a MAC address once and for all, because while that was the original idea, of course everything gets virtualized over time, and especially in the case of phones, it's good to be able to randomize the identity of the phone to make them less easily tracked. Fortunately, the 48 bits of Ethernet space is plenty of room, and some of it is designated for local use, much like 10 dot addresses at the IP layer. And you can always have another layer of protocol that lets phones pick and randomize their identity. But we'll talk about the link layer with the simplifying assumption that everything has a fixed MAC address. On macOS, we can check the MAC address of an interface using ifconfig. So if I run ifconfig and look at EN0, which is Wi-Fi card, we can see that I have an internet address provided by DHCP in my NAT router of 10.0.0.43, but I also have on that interface a MAC address, reflected here as specifically an Ethernet MAC address of 3E.C.5.3C.791E.A.7. If I look at a different interface, like EN1, we see that this interface is not connected to the internet, so it doesn't have an IP address, but it is a piece of hardware waiting to be connected, and so it has a MAC address in case it is connected there. Wireshark is also able to show us frame level information. So if I record DNS packets and I do a dig query, let's restrict it to IPv4 at 8888 as for google.com, and I look in Wireshark, we will see that a DNS query went out. The IP information shows that it's coming from my local machine, 10.0.0.4.3, but also the Ethernet frame is showing that it's coming from my MAC address, 3EC5, so on. So over here on the bottom right, we see these different layers reflected in Wireshark's output, showing the application level, transport layer, network layer, and now the link layer as well as an Ethernet frame.